Assalamualaikum and hi everyone. This is the last part in chapter 1. So in this subtopic, you should understand the concept of limiting reactant and percentage yield. At the end of the lesson, you should be able to define limiting reactant and percentage yield. This is a simple analogy so that you can understand the concept of limiting reactant. Let's say we want to build a bike. So we have frame, we have tires to form a bike. So one frame requires 2 tires so that it can build a bike. But in a certain situation, suddenly we have 3 frames and 4 tires. But finally, there are only 2 bikes that we can build. So, which one is excess? So in this case, frames and tires are the reactant and the bikes are the products. So which reactant is in excess? We can see here that the frames are in excess. So the reactant that is in excess is called the excess reactant. And which reactant is just enough? So the reactant that is just enough in this situation is the tires. So, in this situation, the tires are the limiting reactant. So, in other words, the tires limits the amount of bikes that we can build. After the reaction, only 2 bikes are formed and only 2 frames are used to build this bike. So, we have 1 excess of frame. So, in this situation, this is why the frame is the excess reactant, while the tires are just enough to build 2 bikes. Now let's look at the definition of limiting reactant. Limiting reactant is the reactant that is completely consumed in a reaction. It means that it will be finished by the end of the reaction and limits the amount of products formed. Since limiting reactant is just enough for the reaction, so that is why the products that will be formed is depending on the limiting reactant, while the excess reactant is the reactant that is not completely consumed in a reaction. So usually it will have remaining at the end of the reaction. So in the next slide, we will relate the previous analogy of limiting reactant with the real chemical reaction. The chemical equation for formation of iron sulfide is Fe plus S produce FeS. So 1 mole of ferrum requires 1 mole of sulfur to produce 1 mole of ferrum sulfide. But in a certain reaction, we have 4 mole of ferrum, 6 mole of sulfur, and it will produce 4 mole of ferrum sulfide. So based on this reaction, it can be seen that the ferrum is completely consumed in the reaction, while sulfur has something in excess. Since ferrum is completely consumed to make the product, so ferrum is the limiting reactant, while sulfur will have remaining, so sulfur is the excess reactant. So we can see here, we have 6 mole, but we only use 4 mole. So the balance here that we didn't use is 2 mole of sulfur. So to determine limiting reactant, there are 4 steps. The first one is to write a balanced chemical equation. This is a very important part because you have to make sure that the stoichiometric coefficient of the reactant and product are correct before you identify the limiting reactant. Next, you should have the mole of both reactant. If the number of mole is not given in the question, you have to calculate the number of mole for both reactants. Next, you have to calculate the number of mole of reactant needed to react with the other reactant. And the last part, you have to choose the reactant which will be completely consumed in the reaction, and that is the limiting reactant. Now let's look at this example. So in a reaction, 4 mole of iron is allowed to react with 6 mole of sulfur. So actually this is the similar example as the previous one. So if you have to determine the limiting reactant, step 1, you have to check if the equation is balanced. So we can proceed to the next step, which is to find the number of mole for both reactant. So the number of mole of each reactant is given in the question. If it's not given, then you have to calculate first before we proceed to the next step. So here we have 1 mole of ferrum on the left side, also 1 mole of ferrum on the right side. Now we have 1 mole of sulfur on the left side, also 1 mole of sulfur on the right side. Now the equation is balanced. So we have 4 mole of ferrum and 6 mole of sulfur. The next step is to calculate mole of reactant needed to react with each other in the reaction. So from the equation, 1 mole of ferrum should react with 1 mole of sulfur. So in the question, we are given 4 mole of ferrum. So to find the number of mole of sulfur needed, so 4 mole of ferrum times 1 mole of sulfur divide with 1 mole of sulfur. Actually, this is the comparison. 1 mole requires 1 mole, so 4 mole of ferrum should require 4 mole of sulfur. So theoretically, in an experiment, 4 mole of ferrum should react with 4 mole of sulfur only. But since in the question we have 6 mole of sulfur, it means that the number of mole we have is higher than the number of mole of sulfur needed in the reaction. So it means that sulfur is excess and therefore ferrum is the limiting reactant. So if we have identified which one is excess, so automatically we know which one is the limiting reactant and vice versa. So this is the final part in chapter 1, percentage yield. So percentage yield is the ratio of actual yield from experiment to the theoretical yield from a chemical equation multiplied by 100. So percentage yield is important as an important indicator of the efficiency of a particular lab or industrial reaction. So this is why percentage yield is very important in the industry. So this is the equation for percentage yield. Actual yield over theoretical yield times 100. So actual yield is from the experiment. So in the question, usually it will be given in the question. And theoretical yield is from chemical equation based on limiting reactant. So usually actual yield and theoretical yield is in the form of mass, gram, or any quantitative value. So that's all for part 4. And that's the final part in chapter 1.